Hi class, welcome to the Test 1 review. This will be your first test in chemistry, and this test will incorporate all Regents questions. The major topics on this test are the definition of matter and the composition of atoms. We'll also look at the physical and chemical properties of metals, nonmetals, and metalloids, the identification or classification of matter as pure substances or mixtures, further broken down into elements, compounds, homogeneous mixtures, and heterogeneous mixtures, and the separation of mixtures. Let's start by simply talking about what is matter. Matter is officially defined as anything that has mass and takes up space. All matter is made up of atoms, and all of the atoms that exist in the world are called elements. They can be found on your reference table under the periodic table of elements. Now, the major periodic table of elements gives us the symbols and a lot of information about the elements. If you are not sure about the name that corresponds with each element, or you're looking for additional properties, just turn the page to reference table S. Now let's take a look at the basic structure of an atom. All the different types of atoms that exist in the world will be found on your periodic table of elements. For the first example, we'll look at the structure of a carbon atom and compare it to the structure of all the atoms that exist in the world. From the carbon atom, you can see that there are three major types of subatomic particles. There are protons and neutrons, which are located in the nucleus or center of the atom, and there are electrons, which are located in different energy levels or principal energy levels, also called electron shells, outside the nucleus. This chart explains the basic properties of each of the subatomic particles. We can see that the positive protons are located in the nucleus, as are the neutrally charged neutrons. Be very careful and avoid the desire to use alliteration to assign the charge of the neutrons. Neutrons are neutral and not negative. Both protons and neutrons have a mass of 1. Most of the mass of an atom is concentrated in the center in the nucleus. Again, traveling outside the nucleus are the negatively charged electrons. It is important that you are able to correlate the actual structure of an atom to the symbol of the periodic table. On the periodic table, the atomic number is indicated in bold, as is the atomic symbol. These are both bolded because they are always corresponding. So whenever an atom has an atomic number of 6, its symbol is C for carbon. Whereas if a symbol is K, then we automatically know the atomic number is 19. They always correlate. The atomic number is also the same as the number of protons. Now, since both protons and neutrons contribute to mass, the atomic mass can typically be rounded to a whole number to represent the neutrons plus protons. Now, notice that we are rounding here because this is the average mass of all isotopes. All atomic masses are actually whole numbers because there are never fractions of protons or neutrons. Notice that sometimes the atomic mass on the periodic table may not match an image given to you. Make sure that all of your references match the image or information given to you and are not simply the rounded number from the periodic table. Because protons and neutrons are always located in the nucleus, the charge of a nucleus is always positive. It's always exactly equal to the atomic number. Outside the nucleus, we'll find electrons. The word atom implies electrical neutrality, So in all atoms, the number of protons must equal the number of electrons. Notice in the electron configuration that this symbol between the 2 and the 4 is not a minus, it's simply a dash. So in a carbon atom, there are 6 total electrons and 6 total protons. The positive protons equal the negative electrons, giving the atom an overall total charge of 0. The arrangement of electrons in an atom is given by the electron configuration. Adding the numbers of the electron configuration gives the total number of electrons of the neutral atom. Notice that the electron configuration is read from left to right. The leftmost number is closest to the nucleus of the atom, and as we go further out, the electrons are further and further from the nucleus. The final electron shell, those electrons are called the valence electrons, or the outermost electrons. Now let's see if we can look at 2 model atoms to see if we can correlate the structure to the symbol on the periodic table. So if we look at the atom on the left, we'll see that we have 11 protons. That means the atomic number is 11. So in its symbol, the 11 will go in the bottom left-hand corner. Now when we look on our periodic table, we'll find that element number 11 is sodium. Since we know the atomic number, we also know the symbol. Again, they always correspond. Now to determine the mass number, which will be written in the same position as the symbol in the example on our periodic table, we must add together the protons and neutrons. The sum of 11 and 12 is 23. So this is a version of sodium called sodium 23. Now, if we want to go and write the electron configuration of sodium, we'll simply have to count the electrons in each ring. In the first ring, there are 2 electrons. In the second, there are 8. And in the final ring, there is 1. So when we look at the total number of electrons, 2 plus 8 plus 1, 11, there are 11 electrons and 11 protons. Since the protons and electrons are even, this is called an atom. Let's look at another example. In this example, we have 17 protons. So our atomic number is 17. Looking at our periodic table, element number 17 is chlorine. So our symbol is chlorine. Remember that element symbols must have 1 capital letter, and they may have 0, 1, or 2 lowercase letters. Capitalization is essential, so make sure that you pay special attention to your handwriting. Now, to determine the mass, the neutrons plus protons, we're simply going to add the subatomic particles in the nucleus. So our mass of chlorine is 35. Lastly, if we want to determine the electron configuration of chlorine, it's 2, 8, 7. In both of these examples, the valence electron is in the 3rd shell. Sodium has just 1 valence electron, while chlorine has 7. Some elements are just born heavier than other elements. Elements that have the same identity or number of protons, but different mass, are called isotopes. Here are 2 isotopes of the same element. We know we have the same element because they have the same number of protons. Pause the video and see if you can figure out the atomic symbols. So hopefully you got that these represent lithium-6 and lithium-7. Both of these elements are lithium because they have 3 protons in their nucleus. The number 3 appears on the bottom left-hand corner of their symbols. 3 always corresponds with the symbol capital L lowercase I. To determine the mass, we simply add the number of subatomic particles in the nucleus. The element to the left has a mass of 6, while the element to the right has a mass of 7. Notice that the element to the left, this mass does not round to the same mass as on the periodic table. That is okay. You always want to use the information given in order to determine the atomic symbol. Now, both of these atoms have a nucleus with a positive 3 charge. That's because neutrons have no charge. And both of these species are atoms. They are both atoms because the number of protons equals the number of electrons, creating an electrically neutral particle. Again, 3 protons and 3 electrons make an electrically neutral particle. In order to become more stable, sometimes atoms gain or lose electrons to form ions. Ions are charged particles because protons no longer equal electrons. The charge of an ion is also indicated by the oxidation state. In the beginning of this course, we're primarily only going to be using the first or top oxidation state. To determine the charge of an ion, you'll simply take the protons minus the electrons. Let's look at a couple examples. In this first atom, we'll see that we have a nucleus with a plus 13 charge. We have a plus 13 charge because we must have 13 protons plus an unknown number of neutrons. Any atom that has 13 protons must be aluminum. So this is aluminum. Now we know that we can call this an atom because we have 13 protons in the nucleus and 13 electrons outside of the nucleus. Now, in order to become more stable, aluminum atoms often lose 3 electrons. To find the charge of an aluminum ion, we'll take 13 protons minus 10 electrons, because there are only 10 electrons remaining. That gives a positive 3 charge. Now you try and figure out the atomic symbols and charges for the species given below. Pause the video and come back to see if you're correct. Did you figure out that they were chlorine? Of course they're chlorine, because they each have 17 protons. The species to the left is an atom, because there are 17 protons and 17 electrons. When there is no charge, nothing is indicated in the upper left-hand corner. But when 1 electron is gained, we now have 18 electrons. Having more electrons than protons gives a negative charge. So here we have a chlorine ion. Chlorine with a -1 charge written in the upper right-hand corner. Please note, in chemistry, it is often that we indicate the number before the charge. So here I've written -1, like you'll see in math. But in chemistry, we may write this number as 1 minus. Just like here, instead of writing plus 17, it's written as 17 plus. The chemistry convention and the math convention are not mandatory in this class. You may write your number in either fashion.